Titan is the only moon in the solar system with a thick atmosphere, rivers of liquid methane, lakes of ethane, and a weather cycle, and it is made of ice, not rock. That is not exaggeration. Titan, Saturn's largest moon and the second largest moon overall after Jupiter's Ganymede, is a world with a radius of 2,575 kilometers, larger than Mercury, yet its surface is frozen water ice beneath an orange haze of complex hydrocarbons. Its atmosphere is 90% nitrogen with trace methane, and the surface pressure is about 1.45 bar, roughly 50% higher than Earth at sea level. The first proof came in 2005. NASA's Cassini spacecraft deployed the European Space Agency's Huygens probe, which descended through Titan's atmosphere and landed on January 14, 2005, the first and only landing on a moon of another planet. Huygens transmitted for 90 minutes from the surface, revealing a landscape of rounded pebbles made of water ice, coated in organic material, under a sky that was orange from above and darker from below due to atmospheric scattering. What Cassini revealed afterward was the crisis of Titan's climate. The spacecraft's radar and infrared instruments mapped vast networks of river valleys and confirmed liquid-filled lake beds near the North Pole. Kraken Mare, Ligeia Mare, and Punga Mare are real bodies of liquid methane and ethane, not ice, but actual liquids at temperatures around -179 degrees Celsius. These are hydrological systems, just operating with hydrocarbons instead of water. The methane cycle is real and observable. Titan's atmosphere contains methane that is slowly destroyed by ultraviolet light from the sun, which breaks it into more complex organic molecules called tholins, the orange haze that blocks visible sunlight. These tholins rain down, coat the surface, and are washed into rivers that flow toward the poles, where they collect in lakes. Evaporation from the lakes replenishes the atmospheric methane. It is a complete planetary cycle: evaporation, precipitation, runoff, accumulation, just with chemistry so different from Earth that the water is poison and the rain is liquid natural gas. Because Titan is cold and chemically complex, scientists study it as a prebiotic analog. Before life emerged on Earth, the atmosphere likely contained methane, nitrogen, and water vapor, and UV radiation likely produced similar tholin-like compounds. Titan's surface may preserve the chemistry of early Earth, frozen in time, without the biological processes that later transformed our planet. The surface also holds other bizarre structures. Titan has extensive dune fields near its equator, enormous linear dunes made not of sand, but of solid hydrocarbon grains, shaped by winds that blow in a direction opposite to Titan's rotation because of its thick atmosphere. Cryovolcanic features, possible low-temperature volcanic activity, have been identified near the South Pole, where material that should be frozen may be moving through the crust under internal heat. Titan rotates slowly. One day takes 16 Earth days and is tidally locked to Saturn, like our moon is to Earth. Its thick atmosphere creates heat redistribution, so effective that the temperature difference between equator and poles is surprisingly small, though the poles remain the coldest regions where liquid methane pools. The upcoming Dragonfly mission, a nuclear-powered rotorcraft being developed by Johns Hopkins APL, is scheduled for launch in 2028 and arrival in the mid-2030s. It will land near Selk Crater and fly across Titan's surface, sampling organic chemistry directly. Unlike a rover, Dragonfly's rotor design takes advantage of Titan's thick atmosphere and low gravity, allowing it to travel tens of kilometers per flight. What makes Titan truly strange is not any single feature. It is that every major Earth-like system exists there in an alien chemistry. Weather, rivers, lakes, dunes, atmospheric chemistry, possibly internal heat, all active, all operating under rules that make Earth feel like one possible version of a much broader planetary design. The open question is whether the chemistry at Titan's surface, combined with possible subsurface liquid water interacting with rocky materials, could create conditions where prebiotic chemistry moves closer to something biological, or whether Titan remains a frozen witness to the chemistry that preceded life on Earth. What do you think? Is Titan more valuable as a preserved snapshot of prebiotic Earth, or as a potential site for alien chemistry that might one day be studied up close.